What's going on, everybody? Welcome back to my YouTube channel. Look at this nice and beautiful question on the board that we're going to be solving. And the question says, find the value of x for which x to the 3 over 2 minus 3 to the 3 over 2 is equal to 0. Well, our first step will be for us to decompose this exponent, 3 over 2. So this expression now becomes x to the 3 over 2 is same as 1 over 2 times 3 minus 3 to the 3 over 2 is same as 1 over 2 times 3. And this is equal to 0. Our next step will be for us to apply the law of indices, which says, for example, when I have a to the m, and this is raised to a power of n, the law of indices says take the base, which is a, and multiply the powers, m times n. That means in a situation where I have a base and the powers are multiplying, we can decide to write an expression like this in this form. Now we have a base and the powers are multiplying. We can be able to write this expression in this form. So that means this is x to the 1 over 2 raised to a power of 3 minus, now we're going to be doing the same thing here. This is 3 to the 1 over 2 raised to a power of 3 equal to 0. Now, from indices, a power of half is same as a square root. So this expression can be written as the square root of x. And this is raised to a power of 3 minus, do the same thing here. This becomes the square root of 3 raised to a power of 3 equal to 0. Now we have difference of 2 cubes. So our next step will be for us to apply the property of difference of 2 cubes. For example, when I have a cube minus b cube, which is difference of 2 cubes, this is equal to a minus b times a squared plus ab plus b squared. So this is a property of difference of 2 cubes that we're going to be applying here. Now, by comparison, you see that a is same as the square root of x and b is same as the square root of 3 by comparison. So I'm going to be writing this in this form. So this is a minus b. A is the square root of x minus b. B is the square root of 3 times what I have here, which is times a squared. A is the square root of x squared plus ab plus a is the square root of x times b. What's b? B is the square root of 3 plus b squared. So b is the square root of 3 squared equal to 0. So we've been able to write this in the property of difference of 2 cubes. So let's simplify what we have inside of this parenthesis. So we have the square root of x minus the square root of 3 times, now square can cancel out square root so that we have x plus the square root of x times the square root of 3 gives the square root of 3x plus Now square can cancel out square roots, leaving 3 equal to 0. So we have two cases. So we have case 1. Case 1 is the square root of x minus the square root of 3 is equal to 0. And case 2 is x plus the square root of 3x plus 3 is equal to 0. So let's go with the first case. Now for the first case, we're going to be moving negative 3 to the right hand side. So this becomes the square root of x. As negative 3 crosses to the right, it becomes positive root 3. Now to get the value of x, our next step will be for us to take the square of both sides. So I'll take the square of the left hand side. I'll also take the square of the right hand side. So square cancels square root, leaving x to be equal to square cancels square root to be equal to 3. So from our first case, we got the value of x to be equal to 3, which is a real solution. Now let's focus on our second case in the next slide. Now for our case 2, our first step will be for us to get rid of this square root. And we're going to do that by isolating the square root of 3x. So take the square root of 3x and isolate it, which means we're going to be moving every other item to the right hand side, leaving just the square root of 3x on the left. So this is equal to, so when x crosses to the right, it becomes negative x. When 3 crosses to the right, it becomes negative 3. Now to get rid of the square root, we're going to take the square of both sides. So I'll take the square of the left hand side. I'll also take the square of the right hand side. So square cancels off square root, leaving behind 3x. So we've been able to get rid of the square root. Equal to, now for what I have here, I'm going to be applying a property of a plus b squared, which is equal to a squared plus b squared plus 2ab. So let's apply this property here. Now by comparison, our a is negative x here and our b is negative 3. So let's try and put that into this expression. So a squared, that's negative x squared, plus b squared, b that's negative 3 squared, plus 2ab. A is negative x and b is negative 3. That's it. So we have 3x to be equal to, now negative x squared give positive x squared, plus negative 3 squared gives 9. Now 2 times negative x times negative 3, since we have minus times minus, we're going to be having a positive answer from here. So 2 times negative x times negative 3 gives plus 6x. That's it. So our next step will be for us to move everything to one side. That means I'm going to be moving this 3x to the right hand side. So moving 3x to the right hand side, we have x squared already on the right, plus 9, plus 3x. No, this is plus 6x. So as 3x crosses to the right, it becomes minus 3x. And this is equal to, nothing is left on the left hand side, so this is equal to 0. So x squared, now 6x minus 3x is 3x, plus 9 equal to 0. So we have a quadratic equation to work with. Now for this quadratic equation, it cannot be factorized. And because of that, we're going to be applying the quadratic formula in solving this question. So x for the quadratic formula is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So x now is equal to, now let's substitute. From what we have here, we see that a is a coefficient of x squared, so a is equal to 1. B is a coefficient of x, so b is equal to 3. And c is a coefficient, c is a constant term, and that is 9. So let's substitute this inside of this quadratic formula. So negative b is 3 plus or minus the square root of b squared, that's 3 squared, minus, now 4 times a times c, that's 4 times a is 1, times c is 9, all over 2a, that's 2 times a, which is 1. So x becomes negative 3 plus or minus the square root of 3 squared is 9 minus 4 times 1 times 9 is 36. All over 2 times 1 is 2. So by simplifying further, we're going to be having negative 3 plus or minus the square root of 9 minus 36 is minus 27 all over 2. Let's continue in the next slide. So this simplifies into x equal to negative 3 plus or minus. Now we have a negative inside of this radical. And because of that, we're going to be breaking this down. So this can become the square root of negative 1 times 27. So negative 1 times 27 is same as negative 27 all over 2. So x will be equal to negative 3 plus or minus the square root of, now we can break this 27 down. So we have negative 1 times, now breaking 27 down, I'm going to be taking a perfect square, which is 9 times 3. So 9 is a perfect square, times 3 gives 27. So all over 2. So x now becomes negative 3 plus or minus. Now we're going to be separating each of these terms inside of the radical by using the square root of negative 1 times the square root of 9 times the square root of 3. So this expression can also be written like this, all over 2. So x now becomes negative 3 plus or minus the square root of negative 1 is same as I, which is iota, times the square root of 3, the square root of 9 is 3, and the square root of root 3 is root 3. We're going to be leaving the radical here. So all over 2. So let's multiply the numerator. So we have x to be equal to negative 3 plus or minus. Now I times 3 times the square root of 3 gives 3 root 3i all over 2. Now notice that 3 is common in the numerator. So we're going to be factoring out 3. So x now becomes, bring 3 out. Now negative 3 divided by 3, I'm going to be having 1 plus or minus 3 root 3i divided by 3. I'm going to be having root 3i all over 2. So we have two solutions of x here. So one of the solution is, remember we've got one real solution before. So this is going to be the second solution. So x sub 2 is equal to 3 times 1 plus, I'm taking the positive first, the square root of 3i all over 2. And the last solution, which is x sub 3, is equal to 3 times 1. This time we take the negative minus the root of 3i all over 2. And these are final solutions. So we have one real solution and two complex solutions. Well, feel free to share your ideas in the comment section below. And if you enjoyed this video and have learned something from this video, go ahead and give this video a thumbs up. Subscribe if you haven't. Turn on the notification bell so you don't miss my upcoming videos. And like I always say, until next time, take care.